This lesson is going to talk about a couple different things. We're going to first talk about inverses, we're going to graph a function, and then we're going to learn this thing called function notation. So when you do inverses, really easy. Basically all you have to do is switch your x's with your y's. So literally the inverse of this relation would be all the coordinates in reverse. And then after that you can give me the domain. So it's going to be all the new x values and the range would be all the new y values. So pretty simple for inverses. For the next example, if you notice this equation does not have y by itself, so that's the first thing we want to do. That's a really good habit to do. So if I want to get y by itself, the first thing I need to do is subtract x on both sides. So now I have negative y equals negative x plus 2, and then we're going to divide everything by negative 1. So now I have y equals positive x minus 2. So what we're going to do is we're just going to make a table. And you can just make your table like a t-chart, that's fine. And you need to pick anything you want really to put in for x. It doesn't matter what you pick. Now look at your graph, it's not very big, so picking something like 10 wouldn't work. But we can certainly pick like 1, we could pick 0, and why don't we pick negative 1. So I usually like to do 3 ordered pairs. So if I plug 1 into this formula, 1 minus 2 is negative 1. If I put 0 in, I'm going to get negative 2. And if I plug negative 1 in, I'm going to get negative 3. So now all we have to do is graph these ordered pairs. So we're going to go right 1, down 2, left 1, down 3. And then I just like to connect our lines. And that's it. That's how you graph a line. All right, this is the main focus of the lesson. This is where it gets complicated. So equations that are functions, so they pass the vertical line test, can actually be written in a form called function notation. So before I get on to function notation, I just want to clarify with you guys, you have to remember that based on situations, your reading of something can change. So if I write this, technically that could be read or read, but in order to make sense, I wouldn't say he read, I would say he read. So you have to change the way you read stuff based on the situation it's being used. So in this case, f parenthesis x is pronounced f of x. It does not mean f times x, so we cannot say of means times in this scenario. So in function notation, it means something completely different. The letter f is the name of your function or formula. X will stand for the input. So normally we've been working with equations like y's and x's. And your y value depends on what you put in for x. So if you plug in 0, you're going to get 0. If you plug in 1, you're going to get 3. So we would say that y depends on x. What we'll say in this lesson is in function notation, we say that f is a function of x. So f is going to be the name of a formula. So there's going to be some different formulas and they're all going to have different names. And all they're saying when they write f of x is, hey, the formula outcome depends on x. So it's kind of just like clarifying directions, just to let you know that. So in this example, we actually have 3 formulas. We have 2x minus 1, negative x, and 6 plus x. And all their names, so the yellow formula name is f, the green formula name is h, and the blue formula name is g. So the left side really isn't that important. It just tells us the name of these formulas. The right side is actually where we're going to be doing all of our work. So that's the side we'll be using. So f, h, and g are your names of your formulas, which we call formulas functions in this lesson. And the function is, of course, what we just said, the formula, to which we'll substitute x. And not to overcomplicate things, but you can always change function notation back to what looks normal to you by changing f of x or h of x, g of x, whatever you have, into y. So for example, the yellow formula right now says f of x equals 2x minus 1. So if you really wanted, you can just change f of x into y. And there's nothing wrong with doing that. Here's the problem. Okay, this is when we come into issues. We could also do the same thing for h of x. So right now h of x is negative x. Well, technically you could change h of x into y. Well, here's the problem though. Now I have no way to name these formulas. I can't call them both y. I can't tell them apart then. So the whole purpose of this function notation business is to let you know, hey, I want you to use the f formula. Hey, I want you to use the h formula. If I just gave this to you and said, hey, plug 2 in for x, and you say, which formula? And I say, the y formula. You'd say, oh, well, they're both y formulas. So the whole purpose of the function notation is just to kind of simplify directions so that it's easier to name different formulas. Right. So we're going to have a function notation formula here. It says f of x equals 3x plus 1. So remember, that's the same thing as saying y equals 3x plus 1. So we really don't pay attention to the left side so much, okay? That's just telling us the name of this formula. And all it's saying is, hey, your formula depends on x, and here's your formula. So this is the important part right here. This part's kind of irrelevant. It just helps with naming. So when you see f of 2, okay, that's pronounced f of 2, not f times 2. That means, hey, I want you to substitute 2 into 3x plus 1. That's really what that's saying. But we're not going to write all these words. I'm just going to give you this, and I would expect you to understand that that's what I want you to do. And if you do that, it's really simple math. So you're going to get 7. So if I told you write your answer in function notation, you'd have to write this. F of 2 gets you 7. And what this says is when I plug 2 into the formula, I get 7. It's a sentence basically clarifying, hey, this is how I got it. So it's just kind of this notation thing. We just have to learn to write in this new language. For this example, it's a different problem. A lot of kids will just plug 10 in for x. If I wanted you to do that, I would have written this. These are not the same problem. So you are not supposed to plug 10 in for x. It's a huge no-no. All it says is set 3x plus 1 equal to 10 and solve. Right? That's really different than this example. This example said, hey, plug this in for x. This example said, hey, set your formula equal to 10 and figure out what x is. Hence, it says find x. So if I were to do that, I would get 3. So what that means is f of 3 gets you 10. So in problem 1, I gave you the input, you got the output. In problem 2, I gave you the output, you figured out the input. The good news is those are the only types of problems that you'll ever see for function notation. It's got to be one or the other. So that's kind of what we're going to do in all these examples. In these next examples, we'll be using the following functions, 2x plus 5 and 5x. Just to remember, the name of this function is f, and the name of this function is h. So we don't actually do math on the left. This is just kind of a sentence saying the name of the function is f and x is its input. So that's just kind of directions. So all your work will be done with the right side of the equation. So letter A says f of negative 2. That means find the value of the function if x is negative 2. So we have to plug or substitute negative 2 in for x in order to get that answer. So it looks like we're going to get negative 4 plus 5, which is positive 1. So even though 1 is the answer, it's always good to go back and just make sure you can write your answer in function notation. So you could also word it such that the value of the function at negative 2 gives us 1. So this is basically our answer in function notation. And from that, you can actually graph your answer. Negative 2 is your input, so that is your x, and it corresponds to 1, which is its y value. So you can actually graph your answer on the coordinate plane. All right, let's try it again. So this time we're going to do h of 3. So we're going to find the value of the h function, which is 5x, if x is 3. So when I do that, we're going to get 15. So again, if I wanted to write my answer in function notation, I would simply say the value of the h function at 3 is 15. And then to graph this, you would make this an ordered pair. So the input is 3, the output is 15. All right, so the next example says h of y, and it's okay if this is a letter. It can be anything because all you have to do is substitute y in for x into the h formula. So the h formula says 5x, but this time we're going to write 5y. And that's as much as you can do. You really can't do anything else with that problem. You don't have to worry about ordered pairs. You can't graph something that's not strictly a number. So if it has a letter in it, just leave it alone. Letter D looks very weird because I'm trying to really emphasize this point of simple substitution. So your task is to substitute a smiley face in for x into the f function. So the f function says 2x, or in this case, 2 times a smiley face. So 2 smiley faces plus 5. And obviously you can't do any math with that, so that's just your answer. It's just getting you used to this whole substitution idea, and then doing any math if you can, and if you can't, you just have to stop. So what you can do is go through and try E and F yourself, and then we'll compare answers. So when I substituted, I got 10x for letter E, and I substituted an F, but I did simplify a little bit, and I got negative 6y plus 5, and that's as far as you can go with these. So you just want to circle them, and that just shows that's the most math I can do with what you gave me. So we'll actually stop our lesson here. This is a lot, and then we'll pick up next time with the rest of the example.